Yes, good afternoon, all the participants. Today, the topic of my lecture is applications of geospatial technology, which includes remote sensing, GIS, and also GNSS in natural resources management, development, and governance. I am S.K. Srivastav, and I am working as Dean Academics at this institute, IIRS, at Dehradun. This is the objective of today's session. Basically, it is to sensitize each one of you that how geospatial technology or technologies are currently being used for assessment and monitoring of natural resources and environment, and also for developmental planning and governance, right? So let me, as I mentioned, that this is basically a lecture uh, which is meant for sensitization to each one of you that how this remote sensing technology or the GIS technology, they are being used in societal applications in various sectors, right? So I have made my presentation sector-wise applications, and I'll be sharing each of such applications with you all, and further details actually will be given by other faculty members of IIRS, and whatever I am talking today before you, the details will be dealt in the subsequent lectures on different applications. So with this background, I am starting my presentation with this slide. Now, as you are all aware that Indian space program, it has been built upon for societal applications. That means it is primarily applications driven for solving the problems of the common man. So please understand that not only the space program is meant for searching certain new things as far as space science is concerned, but primarily the space technology or the space science activities in our country, at least, they are being done with primary focus on societal development. In other words, it is basically applications driven. So in this slide, this slide basically shows you different satellites which are available for us from our own system. When I say my own system means the satellites which have been launched by our own country. There are various other satellites which have been launched by many other countries, many other space agencies, including private players. And as far as our country is concerned, we have constellation of satellites. And these satellites, when I say currently, I'm basically in my lecture, I'm talking about the remote sensing satellites. So these satellites, they are meant again for different purposes. As far as the natural resource survey, monitoring and assessment is concerned, or environmental monitoring is concerned, or even the governance and developmental activities are concerned. So each of the satellite has been launched for a particular purpose. For example, if we talk about land and water resources related applications, then we have ResourceSat series of satellites. We do have the microwave remote sensing satellite, which is known as RISAT or radar imaging satellites. So they are essentially meant for the land and water related applications. If you aim to go for the high resolution mapping for cartographic applications, large scale mapping, etc., then we have the Cartosat 2 series of satellite, or even from the radar side, we have the radar imaging satellite 2, which has got a higher spatial resolution. Then we have got certain set of ocean related satellites, which are basically Ocean Sat 2 series, CatSat and Saral Altica. Then there are satellites which are meant for the weather and climate related studies. So they are grouped separately. They are Kalpana satellite, or INSAT, 3D, 3DR satellites, megatropics, and so on. So for different purpose, why I am showing you this particular slide is that we choose different satellite data products for different kinds of applications, which are essentially switchable. So if I want to go for the medium scale mapping of the land and water resources or the environmental monitoring related applications, then resource set kind of satellite data sets are suitable. If you want to procure the images in a season which is basically dominantly cloud covered, particularly the monsoon season, in that case you might go for the microwave satellite or the SAR, the satellites which carry the synthetic aperture radar sensors and so on. So depending upon the need of the application, depending upon the requirement, actually one has to choose the appropriate satellite, and within the appropriate satellite there are sensors. So the appropriate sensor data has to be selected and then subsequently used. So we have a variety of satellites providing us the data at different spatial resolutions, different temporal resolutions, and also at different radiometric resolutions, and we have to use them appropriately as and when required. Now, with this, I have displayed the applications in the water resources sector. So there are some 5 bullets which you see on the left side of your screen. Okay, they are telling about major applications which are possible using the space technology, and let us say using the geospatial technology as far as the water resources sector is concerned. So when we talk about the water resources, the first and foremost information which is required by any water resource manager is basically the information on the spatial and temporal distribution of the water bodies. That also includes, of course, if somebody is working in the mountainous terrain, or in our country, let's say Himalayan terrain, then the information on the glacial lakes is also required. So the paramount thing in the water resource sector is that we should have the spatial as well as temporal information about the presence of the water bodies. Now on the right side of the screen, if you see, I have put 2 satellite images on the top, and these 2 satellite images are basically pertaining to part of Maharashtra, and in the center of those images you see a particular a reservoir which is known as Sagar Reservoir, okay, in Maharashtra, part of Maharashtra. And look at the 2 images. The extent of the water body in the 2 images are different. The reason for that is the date of imaging is different in the 2 images. So if we have the temporal data sets, temporal remote sensing data sets, particularly for this kind of application, we need to use only the optical remote sensing data. But if you want to monitor the water bodies even in the monsoon terrain, in that particular case, you can also use the SAR data sets, but otherwise optical data sets would suffice enough if on that particular date the clouds are not there. So we can use those satellite images for mapping the water bodies, right? And one way of mapping the water body is that once we look at the images, we simply can visually interpret it. That means we can move our cursor around the reservoir and then make a polygon and save it. And that is how, wherever water bodies are there, I can go on interpreting the water bodies and save the polygons, and that way I can prepare the water body map. The second way of preparing the water body map from satellite images, that I can automatically prepare it. Either I can classify the image and come out with land use land cover classification in which water body is a class. The second possibility is that we can use some index. People use normally very popular index called NDWI, normalized difference water index. So if we use that index and then with proper thresholding, automatically or in a semi-automatic way, the water bodies in a given area can be extracted in a very short period of time. So the message here, what I want to give you is that optical remote sensing data sets as well as the SAR data sets, they are suitable for mapping the water bodies wherever they are. And if we want to monitor them, that means how the spatial extent of the water is changing within a water body or within a reservoir or within a lake, then we need to have the temporal remote sensing data sets and map the water bodies and then take it to your GIS package and then see how the water is changing with respect to time. So this is one simple but very, very important application of the remote sensing data sets. Secondly, these days, there are some specialized sensors which are available on board satellites, and those sensors are known as altimeters. So basically, they provide the elevation of the water surface in any water body. If there is a satellite pass and you have the access to the altimeter data, they can precisely tell you the elevation of the water surface. So if you combine the optical remote sensing images, which give you the spatial extent of the water body, and if you happen to use the altimeter data can give you the elevation of the water surface. And if you can combine these two with some ground observations, then one can also estimate the volume of water which is present in a water body. Right. So here is one example which is shown here. On the left side, you have the satellite images, right? So which in the black color in the center, you'll see a reservoir which is Ujjani reservoir in the Maharashtra again. The images are of different rates, and that is how you see the changes in the spatial extent of the water body. But on the right side top image, you see there are on top of the natural color composite, you see some two solid lines. One is of green color and the other one is of cyan color. So these two lines are essentially the passes of the satellite altimeter. And once you acquire the data and process the data and extract the elevation information of this particular water body, you can plot it with respect to time if you have multiple or if you have the temporal altimeter images. So on the left side, the lower picture or lower figure, it shows you how the water level is changing with respect to time. So there are two lines here. Actually, if you look at the graph, there is the orange color line, which is actually the estimated water level, and then there is a cyan color line, which is changing with respect to time again. That is actually the measured on the ground. So you can see there is a very close match between the water level elevation which has been derived from the satellite altimeter as well as the one which has been observed in the field by recording actually the water level elevation. So this slide I have just put it before you that earlier the application was limited to only mapping the spatial extent of the water bodies, but now if the data sets are available for a particular water body in which a user is interested in, then one can also use the altimeter data, and with combining some ground truth observations, one can also estimate the volume of water on a given day. And if you have the temporal data sets, you can even estimate that how the volume is changing with respect to time. So this is another application which has emerged recently for estimation of the volume of water present in the reservoirs, lakes. But only thing is there is some constraint as far as the data availability is concerned. But technically or technologically, this volume estimation of the major water bodies is possible using satellite remote sensing technique today. Then the second bullet, if you see on this in this slide, which is on the groundwater prospects mapping. So as you may be aware by now, since you have attended the basics of remote sensing GIS and the GNSS technology, so you must be aware by now that remote sensing data, even if you have the SAR data, synthetic aperture radar data, microwave remote sensing images, you basically get the surface or near surface information. Whereas the groundwater actually occurs much below the earth's surface. So there is no direct way of inferring, there is no direct way of getting the information about the groundwater. But what geologists do is they try to interpret the occurrence and the movement of the groundwater based upon indirect inferences, and those inferences basically they come from four different parameters, four different basic parameters on the lithology or the rock type of the area, the kind of geological structures which are present in the area, the kind of landforms which are present in the area, and the kind of hydrological, or let us say the recharge conditions which are occurring in the area. So if we can derive the information about the rock type, structure, landform, and the recharge conditions, we can always integrate that information and come out with the inferences about the groundwater. So that is the basic hypothesis of groundwater prospects mapping. And very important program, it was taken up quite some time back using remote sensing images or satellite images, and that program is actually known as nationwide groundwater prospects mapping, and it was done topographic map wise at 1:50,000 scale for the entire country, right? So I will just show you how that map looks like. The on the left side, the map which is shown here is actually the groundwater prospects maps, and there are different symbols which are shown on the map, different colors with different hatching patterns are shown here. So the color actually represents the prospects of the groundwater in terms of that what kind of wells are suitable in a particular area, what kind of well yields are possible in a given area, and also what should be the depth range of the wells which should be drilled in a particular area. So these maps, basically the groundwater maps, they are available today for the entire country at 1:50,000 scale. So they provide you the information about in a semi-quantitative manner, that where what kind of groundwater prospects exist. That is number one. Number two, another information which is provided in these maps is that which type of groundwater recharge structures are suitable. So these maps are basically, although they are being called as groundwater prospects maps, they essentially serve two purposes. One is to depict the groundwater prospective zones, and secondly, the zones which are suitable are the tentative locations are suitable zones which are where we can put up the groundwater recharge structures. And essentially these maps were prepared for solving the drinking water problems in our country. And these maps, they have been used across the country, particularly in the hard rock terrain. And let me share with you that the feedback which has come from the groundwater departments of different state governments, it has been very, very encouraging. And particularly in the hard rock area, the success rate of the wells, it has increased tremendously. Also, using the scientific information which is available in these maps in terms of the geological, geomorphological, and hydrological information, and in terms of the suitable zones where the recharge structures can be put up, that information has been used by the groundwater departments to locate thousands of groundwater recharge structures. So these maps, the groundwater prospects maps, they have served a very, very important purpose for solving the drinking water problems in most parts of the country. And also let me share with you is that all these maps, the groundwater prospects information, they are being available in the public domain. They are made available in the public domain, and they are hosted in the Bhuvan portal of ISRO, which is essentially a portal hosted by National Remote Sensing Center. at Hyderabad, which is one of the ISRO centers. So within that Bhuvan Geo portal, you have a web page for Bhujal. There is a Bhujal application. So if you type Bhuvan Bhujal, you will get into, or you will enter into the application related to groundwater, and wherein you can visualize all these maps which are available, which were prepared under this project, and they are made available under this Bhuvan platform. And as far as the information content is concerned, there is a big legend, very long legend. So even if I show you in my presentation, you will not be able to read that. But I have put the kind of information which is available in the map in the legend. So basically, it provides the information about geology of the area. It provides the information about the geomorphic units of the landforms. It provides the information about depth to water table. It provides the information about discharge conditions, and it also provides the information about what kinds of discharge structures are suitable and where they are suitable. Some tentative locations are shown, and types of wells which are suitable, depth range of the wells which are suggested, and yield range of the wells which is expected. So this kind of information is available in these maps. Then there is another very important application within the water resources sector, which is in the field of cryosphere studies. That means we deal with the mapping and monitoring of snow cover and the glaciers, particularly in the Himalayan terrain, and also development of snow melt runoff forecasting models. So this is another very important area as far as the water resources applications of satellite remote sensing is concerned. So I will show you a couple of slides in this particular domain also. So if you, this is the image from our ResourceSat satellites, LIS-4 camera multispectral image of September 2012 of an area which is covering the Gangotri glacier, which is covering from where the Bhagirathi river is actually originating. And then we also have, so this is basically the Gangotri glacier, which is present on the western side of the image. Then on the eastern side, we have the Satopan glacier and the Bhagirath glacier, from where actually the Alaknanda river is originating. So if you look at this particular image, you are seeing some white color, and then you are seeing some valley glaciers, which are very predominantly seen on the image. So the white color features are actually primarily they are snow cover, but there are at places there is like these ones on the southern side, particularly you see a lot of cloud cover also. But the appearance between that cloud cover, the kind of let us say the morphology or kind of topographical behavior they exhibit, the snow cover can be differentiated very well with the clouds. And clouds, definitely they are always associated with their shadows. So that is how one can do the discrimination between snow and cloud, because both of them they appear white. And also many times people use different combinations of different band combinations of the satellite images. And if you use the SWIR band particularly, one can very easily discriminate between the cloud and the snow cover. So snow cover mapping, if you want to map the snow cover like the way I was showing you how to map the water body, similarly, you can also map the snow cover in the Himalayan terrain or in any terrain where the snow is present. And also even you can map the glaciers based upon the visual interpretation, as well as by applying some automatic or semi-automatic methods. So if and why we need to do this? Once we need to do this because water resources managers are basically, they want to know in advance that how much water will be available in the snow-fed or the glacier-fed rivers during the summer months, because during the summer the rains are not there, and primarily the water will be present by the melting of snow and the glaciers. So people, they what they do is they run the snow melt runoff forecasting model or any other hydrological model and come out with the estimation of the kind of flow which will be available through snow melt or the glacial melt runoff. But one of the most important inputs which is required in these models is the aerial extent of these snow cover, and also even the glacier cover. These days, of course, there are certain more parameters which are required in the model, but this is the primary thing. That means the spatial extent or the aerial extent of the snow cover and the glacier has to be inputted into the model, and this information essentially comes from the satellite images. So when we have the temporal images, I can go on taking image every day or every 2 day or every week. I prepare this snow cover map, and that those maps they go as an input to the hydrological model or snow melt runoff forecasting model, and based upon that, the forecasting of volume of flow which will be available in the stream fed or the glacial fed streams which will be available. It is forecasted. So today actually the forecasting in the Himalayan basins actually is done in 6 major basins: Chenab, Beas, Satluj, Alaknanda, Bhagirathi, and Yamuna. And you can see the graph on the bar diagram on the right side, bottom right, wherein the green bar actually is indicating the forecast volume or the forecast runoff volume, which is forecasted through the model, and the blue bar actually indicates what has been observed by gauging the spread. So there is a very good match, and this work is done on an operational basis for these 6 river basins by National Remote Sensing Center at Hyderabad. And on the left side picture, you see it is actually an animation wherein the satellite images for the entire Western Himalaya, including the states of the Uttarakhand, Himachal Pradesh, and Jammu, J&K, it has been taken, and the snow cover has been mapped. It has been extracted for every week, and then the animation has been generated. So every week, how the snow cover is changing with respect to time is what is shown in this particular image, which is available to you on the left side. So this information is very, very critical about if you want to monitor in long term that what kind of changes are happening in the upper parts of the Himalaya as far as the snow line is concerned, or let's say the changes in the glaciers are concerned, whether they are retreating or they are advancing. If they are retreating, at what rate they are retreating. If they are advancing, at what rate they are advancing. Is there any change in the mass, in the glacial mass? So that kind of studies, for that kind of study, the satellite images are being used by many of the people around the world. Yes, sir. Next, we will see there is an animation wherein number of satellite images they have been kept. They have been superimposed one over the other, and then animation has been developed in which you will see, you will get a feeling as if the glacier is moving. And in fact, actually, the glaciers move with respect to time. Okay, so although their velocity is somewhat slow, but in this animation, you can see this is the animation for the Gangotri glacier, and you can see the glacier moving towards northwest. And you can, at the same time, you can also see that how this snout is retreating towards southeast, right? And you can see the stream which is moving upstream for the Bhagirathi river, which is moving for upstream because of the retreat in the Gangotri glacier. So this kind of animations one can these days create and use it for glaciological studies or cryosphere related studies. And today you have the satellite, the images available from the synthetic aperture radar data sets, and using the technique called differential SAR interferometry, one can also estimate very precisely the velocity of the glaciers using the SAR data sets. So this is another possibility, and many of the people these days they use the SAR data sets for mapping and monitoring the velocity of the glaciers which in turn provide the information about the mass changes in the glacier. And then there has been also very interesting application in the field of water resources, which is shown here in the as the fourth bullet, which is on irrigation infrastructure monitoring and performance assessment. So this is also a big area. Suppose like irrigation network, irrigation infrastructure is being developed in certain area. So if you want to monitor them, that how the development has taken place, whether there are any shortcomings, or if all the networks irrigation sources are linked together or not, you can monitor that using high resolution satellite images. And so this is another very important application. On the bottom right, if you see, there are some high resolution images in black and white, and the white color linear features what you see are basically the canals, and you can see yourself that ideally these canals they should be linked with each other. That means they should be connected with each other, but you can see certain gaps. So such kind of gaps can be identified even without going to the field, and you can such information can be extracted and provided to the people who are working in the field that well there is a gap, address this particular thing. So high resolution satellite images, they have been found to be very effective in monitoring the irrigation infrastructure particularly. And then the basin wise water resource assessment. Of course, you cannot directly estimate how much water will be available in the entire river basin, but what is basically done is the inputs which are required for the hydrological models. Many of the inputs, whether you talk about the digital elevation models or you talk about the slopes of the slopes in the of the area of the study area, or you talk about the land use land cover change and how they are changing with respect to time. You talk about the soil maps and so on. So there are many inputs which are required to be given to the hydrological models for water resource assessment. So many of them actually they can be derived nicely from the satellite data sets, and then it can be provided to the hydrological model. So these are the major applications of water resources. Now I will go to another sector, which is again a very, very important sector. It is actually geology and mining related sector. So as you are all aware, suppose you want to go for any kind of developmental activities, one wants to make the road between two different points connecting two different towns or cities or whatever, particularly in the hilly area, or you want to make a tunnel, or you want to make a dam, or you want to make a reservoir. I mean, any kind of engineering geological investigations, particularly for mineral exploration, for various environmental geological related applications, mining related applications, there are possibilities from the satellite remote sensing data sets these days. And let me also tell you that geologists were the first users of the remote sensing data in 60s, particularly when they were using the aerial photographs, and subsequently with the availability of satellite images, they have been using that. So the fundamental requirement as far as geological information or geological application is concerned is the availability of the geological maps. So geological maps traditionally they are prepared using field surveys, conventional field surveys, and while doing that, even the geologists they use the remote sensing data sets. When I say remote sensing data sets, they used to use aerial photographs and also the satellite images these days. And even if the area is mapped and you have a look of the same area with this satellite image, you will find there are certain places where the lithological boundaries they can be updated. At many places, you will find that there are number of geological structures which you can see on the satellite images. They are not available on the geological maps. So that way, the geological maps can be updated even today, even in the well-mapped areas. So the fundamental information about the geology, that means about the rock types, particularly the lithological discrimination and the geological structures, is being provided by the satellite images. Number two application, the second bullet, if you see, there is a very important application on the landform mapping or the geomorphological map. Okay, so because the landforms, it is something which you see on the surface of the earth, and satellite data sets, they provide the surface information essentially. So landforms can be mapped very nicely, and that is how a national mission was taken up in our country a few years back, wherein the satellite images coming from the Indian remote sensing satellites, they have been used for preparing geomorphological maps at 1:50,000 scale for the whole country. And this particular thing was done jointly by ISRO and Geological Survey of India together, along with the help of many of the state remote sensing application centers and also with the academic institutes. And these maps, even the geomorphological maps and also the lineament maps, they are made available on the one platform and also in the GSI portal, right? And the geological maps, what I am talking to geological maps, if somebody wants to see the geological maps, get access to those geological maps, one can also visit the portal, the GSI website, and they have got a portal wherein you can see those geological maps. Then the third bullet, if you see, the geological inputs for the national groundwater prospects mapping. So this groundwater prospects mapping, I have already talked in my when I was discussing about the water resources related applications. So there, anyway, the geological information, groundwater is basically a subject in the geology. So the inputs for groundwater prospects mapping are actually related to geologists. So the geologists who are trained in photogeology or who are trained in interpretation of the satellite images, they try to extract the information about the fundamental information about the lithology or the rock types, structures, landforms, and then they integrate these information along with the well information, the wells which have already been drilled. So what kind of wells which have been drilled, what is the yield coming out of that well, at what depths the aquifers are existing, and so on. So it is basically an integration of the ground-based as well as satellite-based information, and then the groundwater inferences are being made. And that is put up in the groundwater prospects map. And as I told you earlier, these maps are available in the Bhuvan Bhujal portal. Then there is another important application is on landslide hazard zonation or landslide susceptibility zonation, particularly in the hilly or mountainous terrain. This particular problem of landslides is very common, especially in the monsoon season. So there have been initiatives earlier that wherein the remote sensing data sets, they have been used for mapping the basic geological parameters and also other related parameters, which are then integrated to prepare the maps showing that which are the vulnerable zones or which are the more susceptible zones, which are the less susceptible zones, which are the moderately susceptible zones, and so on. So the landslide hazard zonation maps have been prepared for certain areas, not for the entire country, or not for the entire hilly terrain in our country, but for certain important road corridors in Uttarakhand and in Himachal, Himalaya, and also in the northeastern states. They have been prepared using satellite images and also other information which is available from other sources and the ground truth information. And that information again on the landslide hazard zonation is available in the Bhuvan portal. You can always go through and see. Now, these days, Geological Survey of India, they are the focal points, they are the nodal agencies for systematically mapping and monitoring, and also for preparing the landslide susceptibility zonation maps in the entire country. So currently the work is in progress in the Himalayan terrain very systematically at 1:50,000 scale. So here also, as I mentioned, satellite images have an important role to play. Mineral targeting for carrying out further investigations on the ground, whether it is geophysical or geological or geochemical surveys. But basically the purpose here, purpose of remote sensing, using remote sensing for the mineral exploration related work is that if we are working in a large area, we try to find out some suitable areas, some favorable areas, thereby reducing the area of investigation on the ground which ultimately which in turn reduces the time and cost of the investigation. So again, there are certain indicators which the geologists they try to map using satellite images, and, and that work is followed up on the ground. Recently, it's not recent, actually relatively recently, you can say from 90s onwards, actually there are hyperspectral remote sensing data sets are available, wherein for any given pixel or for any given image element, one can have the entire spectral profile of the material. So that spectral profile of the material is interpreted in terms of the presence of any mineral of importance to a user. Okay, so that way, these days, a lot of people they are basically concentrating on the analysis of the hyperspectral remote sensing images for identifying the particular minerals. And then once you identify the particular minerals on the surface, then you try to integrate that information with other information, and then go for the field works or field surveys for taking up further investigation. So this is another area. Then geo-environmental impact assessment of mining. So wherever mining activities are actually going on, there is a lot of changes in the land surface. There are a lot of changes in the land use, land cover, and so on. Satellite images, you can use them very nicely for monitoring the kind of changes, land changes which are taking place in and around the mining area. So this is one application. Second application these days, which is very, very important, is even mapping and monitoring the illegal mines. So if you have the high resolution satellite images, one can always find that where the mining is going on, and then on top of the image, if you superimpose the leasehold boundaries which has been given to the people, to the companies for mining. So any mining activity which is lying outside the leasehold boundaries, you can always demarcate that, delineate that, and that could become the potential sites where the illegal mining activities are going on, and then subsequently you can visit that. For confirming, you can visit that on the ground. So this is another illegal mining monitoring illegal mines is an important activity which has emerged in last few years with the availability of the satellite images. That is currently going on. So, and then as I mentioned in the beginning, that any kind of engineering geological project, whether it is a site selection for the hydropower sites, or it is for the road alignment, or it is railway alignment, particularly in the hilly terrain and so on, a lot of geological inputs are required to be generated. So the satellite images, they are primarily being used these days for generating such inputs. Of course, let me mention here that two fields, particularly the field of geology and field of soil science or soil survey, they require a lot of inputs from the ground. But only thing is that if somebody is trained in the photogeology or in the interpretation of satellite images, the field works can be planned in a much better manner so as to reduce the time and cost of the investigation. So that is the beauty of the satellite remote sensing as far as the geological applications are concerned. Now I am moving to the different sector, which is the agriculture sector, and here I will highlight to you is the major operational programs which are currently going on in the country. On the right side, there is a picture wherein you can see that there is a list given within the circle. There are some text written. Those texts are actually the applications of remote sensing, satellite remote sensing in the domain of agriculture. So which includes crop area estimation, production forecasting, drought assessment, horticulture assessment, cropping system analysis, and so on. So there are various applications possible in the agricultural domain. But there are certain operational applications which are currently going on in our country, and that this operational work which I am going to highlight to you, it is being carried out not by ISRO, it is being carried out by the Ministry of Agriculture of the government. There is a center in the Ministry of Agriculture that is known as National Crop Forecast Center. So they do a lot of agricultural, remote sensing agriculture related studies for providing inputs to the government of India, or those are basically policy inputs for deciding the import export policy and also for the other purposes. Let us see what are those major operational programs. The first program, which is very important, is known as FASL program. FASL is an acronym which stands for forecasting agricultural output using space, agrometeorology, and land-based observations. So here, what is being done is that the crop-related information, that means particularly the cropped area for different crops, is actually mapped from the satellite images, and that information is then integrated through the crop yield models by combining the satellite imagery information, the agro-meteorological information, and other land survey-based information. And forecasting of agricultural outputs is being done for 8 major crops at district level for the entire country. So, and these 8 major crops are, they include rice, both in the Kharif as well as in the Rabi season, wheat, rapeseed and mustard, jute, cotton, sugarcane, potato and sorghum. So these 8 major crops, they are monitored every year using satellite images, and how much production is going to be there for these 8 major crops before the crop is harvested. Please understand that these works are being done before the crop harvesting takes place. So before the crop is harvested, the production estimates for these 8 major crops are being done by this National Crop Forecast Center using the data sets available from the Indian satellites as well as from the foreign satellites, and by combining other information. And they provide this information to the government for deciding that how much, whether we have to import a particular food grain, or we can export, and so on. So as a policy input, the satellite remote sensing data sets are being used for deciding export-import policy of the agricultural food grains. Second major operational application today, which is being carried out again by the same center, is on National Agricultural Drought Assessment and Monitoring. In short, it is called as NRMs. So under this particular program, NRMs program, as you are all aware that India is basically a drought-prone country, and 17 states in our country, they have been identified as the drought-prone states. 17 states they have been identified drought-prone states in our country. So using remote sensing data and using also some other ground information, the agricultural drought assessment is done every 15 days, once in every 15 days at district level, and the information is passed on to the state government as well as the district administration for taking up actions on the ground. And this is done on an operational basis during the monsoon season, and currently the research is going on at how to provide this kind of information on the agricultural drought even in the Rabi season. Also, there is a lot of research because, as I mentioned to you, that under the FASL program, the information is being generated on 8 major crops, but the requirement is to go for something like 25 crops and so on. So currently, the research is in progress within ISRO system, that how the satellite data sets can be used for improving the information for going from 8 major crops to something like 25 major crops. And so for some of the crops, success is already obtained, and very soon they will be added to the list within this operational FASL program. Then the third program is actually a Chaman program, and Chaman program is actually on horticultural assessment. So under that Chaman program, there are 7 major horticultural crops: mango, bananas, citrus, potato, onion, chili, and tomato in 12 states covering 185 districts. It is being monitored, and the information is being generated and provided to the respective people for various policy issues. So very very important field of agriculture, and a lot of inputs from remote sensing data sets are being provided on an operational level. And also there are many things in the research phase currently. The success stories are available. Only thing is that we have to really make them operational so that the country-wide application or the nation-wide application becomes possible. Then the next sector I take is the forestry and environment related sector. And here again, there are several things which are possible. And let me tell you that India is one of the countries. India is one of the countries where the forest cover monitoring using satellite remote sensing technique or satellite remote sensing data sets is being carried out once in every 2 years. And this work, like agriculture, it is being done by the National Crop Forecast Center within the Ministry of Agriculture. The forest cover monitoring, if you look at the first bullet, forest cover monitoring is being done by Forest Survey of India, located in Dehradun, and they use primarily the satellite data products along with the ground information, and then they generate the forest cover status report once in every 2 years. Okay, so that is a very, very important contribution coming, nationwide contribution. Again, it is not done for a small area, it is being done for the entire country. And you can imagine the size of the country, which is something like 3.28 million square kilometers. So it's a very big area, very large area, and this kind of information is currently being generated. On the right side, top picture, if you see, it shows an animation that how the forest cover is changing with respect to time from sometime in 1997 to 2009. So over a period of 12 years or so, you can see in the lower portion of that image how that green wash, which is actually the forest cover, is decreasing, and in place of the where the forest cover is decreasing, the agricultural practices of the croplands are coming on. So this is one of the very good examples of how anthropogenic changes in the land use and land cover is taking place, and that can be very well monitored using satellite images. So forest cover change monitoring is very much possible using satellite remote sensing. Then we have another application, again very, very important application, and you might have heard that particularly during the summer season, somewhere around February month onwards up to May or even up to June, in many of the areas forest fires take place. So we need to have the information, near real-time information about where these forest fires are taking place, so that if that information is available and if it is provided timely to the people who are working on the ground, they can always address that particular issue, to quench the fires or to take actions on the ground. So towards this, again, the satellite images are being used for forest fire detection on an operational basis. So here, let me share with you the data sets from satellites. They are being obtained every day 6 times. Every day 6 times, and as soon as the data is obtained from a given satellite, within around 20 minutes of time, the satellite data is processed, forest fire information is generated, and it is passed on to Forest Survey of India. And from ISRO side, and in Forest Survey of India, they superimpose the forest administrative boundaries and so on. Basically, they do the value addition of the forest fire products, and then that information is passed on to the people who are working on the ground in different forms, including the alerts, SMS alerts, which are sent to the people on the ground to take actions wherever forest fires are there. So this is another very big area wherein in near real time the forest fires are being detected, mapped, monitored, and then actions being taken on the ground. Also these days, not only satellite remote sensing, people are also using mobile applications, So, and those mobile applications, using those mobile applications, people can geotag the forest fire locations. It can be done by the government officials. It can also be done by the public. Okay, so once that, if anybody sees the forest fire in any given area, one takes the picture and automatically through that mobile application, the location is recorded, the photograph is taken, and any information, textual information, if it is given, it can be provided in the mobile application, and once the data is sent, it goes to the central server, and wherein people, the responsible people who are monitoring the forest fires, they can immediately take the actions on the ground. So this is another way, of using the geospatial technology, wherein the mobile application comes very handy. Then another major program which was taken up, it was on biodiversity characterization. So entire country, the biodiversity characterization that has been done at landscape level at 50,000 scale, of course. And the most important output, there were a few outputs, but the most important outputs which has come up under this particular program of biodiversity characterization at landscape level is the biological richness map. So for entire country, the biological richness has been prepared, and the areas which are basically containing the high richness or very high richness, these are the areas which should be used for the conservation planning and various actions by the people who are meant for that. Then there are also other applications, forest type mapping, biomass mapping, and carbon accounting. These days, the sensors, this radar data sets, and also the LIDAR, satellite-based LIDAR, or even the terrestrial LIDARs, if the data sets are available to you, one can do the quantification of the biomass, and then that biomass can be converted in the form of the available carbon. So this is another major applications. The lot of success stories again in our country, they have been demonstrated in different areas, in different forests. Only thing is that on an operational basis at countrywide scale, it has to be taken up. And let me also share with you that there is a very important mission which is coming up in near future in collaboration between ISRO and NASA, and that satellite is called as an ISR. Most likely that satellite is going to be up next year. So one of the important applications, that is a synthetic aperture radar satellite, NASA ISRO synthetic aperture radar. So that provides data in the L band as well as the S band of the microwave region of electromagnetic spectrum. And those data sets will be very useful for quantifying the biomass available in different forests. So that is something, there is a lot of scope of using the radar remote sensing data, particularly in the near future, as far as the biomass estimation is concerned. Then those data sets are also being used for wildlife habitat monitoring, eco-sensitive zonation, and things like that. Okay. So there is one animation on the bottom right, which is showing you the forest fires. So you can see the green wash, which are the intact forest cover, but you can see also a lot of haze. And those haze are being generated because of the forest fires. Those haze are actually the smoke which is generated because of the forest fires. And if you further zoom it, you can see the forest fires. So this kind of animation can be generated using satellite images and then provided also to the people on the ground. Then there is also a lot of work being done towards developmental planning, towards infrastructural planning. So a lot of data sets, particularly on the land use, land cover, they have been generated. A lot of satellite images, also rectified satellite images at different scales, they have been generated, and they are available in the public domain. In fact, most of them, they are available in the Bhuvan portal of ISRO. And here I would like to make a mention before all of you that any kind of developmental planning one has to do, so the fundamental information which is required is the information about the land use. So the land use, land cover is being mapped for the entire country at 3 different scales. One is the scale of 1:250,000, that means 250,000 scale, and that 250,000 scale information is generated every year from 2004 onwards. and that information is available in the. Then the land use land cover maps are being also generated at 50,000 scale. Okay, at every 5 years interval. So first cycle took place in was generated the first land use land cover map of India was generated in using the data set of 2005 and 6. Second cycle was taken up in 2011-12, and third cycle was taken up in 15-16. Then after another 5 years, the next cycle will be taken, and so on. So every 5 years, the land use land cover information on 50,000 scale is available. It has been extracted, it has been prepared, and those maps are available again in the form. Third thing is the land use land cover maps are 10,000 scale. 10,000 scale, they are available for the entire country. Of course, only one cycle has been completed, and the second cycle is currently going on. And that first cycle where the mapping has been completed at 10,000 scale, it is also available in the. So land use land cover information at different scales, both spatially as well as temporally, they are available in the one portal. Okay, which people can use it for developmental planning at local level to the regional level. The second thing, important thing which I want to convey before you is that these days a lot of activities are going on in monitoring the developmental activities, right? For example, if you look at the two pictures given on the left side, okay, there are two images given. One image is demonstrating that how to monitor the plantation activity using high resolution satellite. So if you see the first picture, you will see basically the agricultural land or the crop land, but which are basically barren. Very few places you see some green dots which show the vegetation, but otherwise more or less it is lying barren. But look at the bottom picture, you will see many of the areas they are covered with the plantations. They are showing green color now, and you can see those dots which show the individual plants because it is a high resolution image. So there is a huge difference between the top image and the bottom image, and that is how one can monitor the plantation activity. Similarly, these days a lot of funding is being done for watershed management programs. So whether those measures, the watershed management measures, they have been actually taken up on the ground, whether the conservation structures have been made on the ground, water conservation structures or groundwater recharge structures, they have been made on the ground or not. There are two ways of doing it. One is that either you go to the field and check for yourself whether it is existing or not. Second way is that you use the high resolution satellite images and interpret them to see whether actually they have been those measures, whatever we are talking about, whatever the construction activity which was supposed to be taken up, whether it has been done nicely or not. You can monitor it using satellite images. So on the right side, if you come, the top photo is actually the satellite image, and the bottom two photos are the ground photos. Okay. So wherein the farm pond, one of the farm pond which you see on the image very nicely, and also in the ground photo. So you can see the way you see it on the ground photograph, the same way you see it on the satellite image. Then there are contour trenches which you see in the photograph, that is, and similarly they appear on the satellite images as well. So suppose somebody claims that we have made contour trenches as part of the watershed management scheme in a given area, and this much area we have covered or not covered. If you want to check it, you can always use the satellite images and see for yourself whether it has been done or not. So a lot of funding being done for road making. So what is the progress? I mean, you can monitor the progress of the work using satellite images, whether the road has been made or not. If it has been made, then up to which particular place and so on. So monitoring of the developmental activities these days is very much possible and is being used. It is not theoretical; it is actually being used by the people, by the respective ministries for monitoring the various funded schemes of the government, both at the central government level and also at the state government level. Then there are many other projects programs which are currently going on or which are possible using satellite images. One of the important applications is in the field of urban and regional. So you might have heard one of the major initiatives which has been taken by the government of India. It is known as Amrut mission, okay, Amrut program. So under the Amrut program, for something like in the first phase, something like 500 cities and towns, maps at 1:4,000 scale are being generated. So for that particular purpose, 50 centimeter resolution images are being taken, they are being interpreted, and the maps are being prepared in the GIS data formats, and they are being made available to the urban local bodies for further collection of the field-based data sets and then use it for the urban planning. So this is a major program where remote sensing is providing a very important or very significant role. Then there are other things possible. I will not be able to go through each of the applications because of shortage of time, but few of the things will be discussed by our faculty in the coming days. But Amrut program is one such program wherein satellite data sets are being used in a big way actually. Okay. Then another sector which is again very, very important is the ocean and atmosphere sector. So all of us we watch the weather report more or less every day in our TV. So and we also must have noticed that the weather reports these days they have become very, very accurate. Okay, thanks to the availability of the satellite images at very short interval of time. Today, from the Indian systems, from our own Indian weather satellites, we have the availability of data sets at every 15 minutes. Okay, so with that availability and with the advancement in the processing, computing technologies and so on, availability of models and all, so the weather prediction has become much more accurate. And let me also tell you that weather prediction for the Blue agency for the weather prediction is actually India Meteorological Department. So they use essentially the weather satellite data, and they use different models for giving you the information about the weather and also the weather forecast. Weather forecast actually is being generated essentially with models. Then the cyclones, particularly the east coast as well as the west coast of India, they are highly prone to cyclones. So starting from the genesis of the cyclone to the date of landfall, time of landfall, and also even further, you can track that how the cyclone is approaching the land and so on from the ocean land. And using the models, one can also forecast that this particular cyclone, it has originated this place and it is going to have landfall at this particular place on this date and at this time with very high accuracy. Okay, and that has become possible these days, and you can see that these days, even if the cyclones are coming, the frequency of cyclones is more or less same, or even rather it has increased, but the damage or the loss of life actually it has reduced drastically, and many of the areas you see now you'll hear the numbers less than 10 or so. So wherein earlier people used to die in numbers of 10,000 or even more. So that kind of change this technology has brought in because of the high temporal availability of the weather information available from the satellites. Then in the ocean sector, very important satellite information is being generated, that is known as potential fishing zone forecast. In short, it is called as PFZ forecast. So all along the eastern coast and the western coast of our country, actually the satellite images are being processed, and based upon the chlorophyll concentration in the sea waters, based on the temperatures of the sea surface temperature, by combining these two information, the scientists, they are generating the information, which are the zones, which are the suitable zones or favorable zones where fish catch is most likely to be there. The high fish catch is most likely to be there. So this particular program or the project is known as potential fishing zone forecast, fishing zone mapping, and as well as forecast. So it is being done through the satellite images, and it is done by Ministry of Earth Sciences. There is a center called INQUIRES, Indian National Coastal and Ocean Information Services, located at Hyderabad, and they do the satellite image processing and they provide the information to the fishermen community using the satellite data. Ocean state forecast, basically how rough the ocean is essentially, is also being provided through the satellite images by processing satellite images, which is very, very useful, particularly for the navigational purposes. Right? So this is another very, very important sector where satellite image remote sensing is playing a big role. Then the last sector which I am covering today is the disaster management support sector. So we do not do disaster management per se using the remote sensing, but what we do is that we provide geospatial inputs for supporting the disaster management. Okay, so there is a difference between disaster management and providing inputs for disaster management. The role of satellite remote sensing is actually providing inputs for supporting disaster management activity. So, as far as disaster management is concerned, the Department of Space and particularly National Remote Sensing Center, one of the ISRO centers at Hyderabad, it is identified as as the nodal agency for providing satellite-based information for different disasters, and these disasters are floods, cyclones, landslides, forest fires, and earthquakes. So flood mapping is actually done by NRC during every year during the monsoon season. Cyclone, primarily the cyclone tracking and prediction is done by the IMD, India Meteorological Department, under the Ministry of Earth Sciences. But because of the cyclone, how much area is inundated, how much area is affected, and things like that, that mapping is carried out by the National Remote Sensing Center, NRC. Landslides, wherever the landslides they occur during the monsoon season, how much damage they are causing, in terms of the rapid damage assessment at the coastal scale, and also, as I discussed with you, forest fires, and whenever earthquakes occur, so what kind of damages the earthquakes have caused. So for floods, cyclones, landslides, forest fires, earthquakes, and there is another application which is not actually considered as disaster, but it is a hazard, you can say, which is agricultural drought. So agricultural drought assessment is done by the National Crop Forecast Center. That is also done every year in 17 agricultural drought prone states in the country. Then not only the remote sensing data sets, but even the satellite communication is also very, very important for supporting the disaster management activity, because during the disaster times, it so happens that the terrestrial communication links they fail, and at that point of time, the satellite communication works. So that is another very important input as far as the space technology is concerned. So emergency communication. So they provide emergency communication systems during disasters. And then we also, as a country, India provides support to international disaster. There's a charter on international disasters in which the member states or the member countries, they are supposed to provide the satellite data sets free of cost to other countries wherever the disaster has struck. So we, in this, being part of this international charter on disasters, ISRO or India, let us say, we get the data free of cost from foreign satellites. Similarly, we also provide the data free of cost from Indian satellites to other countries. So this way, the disaster management activities is a full-time 24/7 activity which is done at National Remote Sensing Center at Hyderabad. These are some of the important portals which you might, whenever you have time, you can have a look at it. All the time I was referring to one portal, and I'm sure that people who have done the courses in the basics of RSGIS, you must have had the demonstration also on the Goan platform. So it's a very, you can say it's national geo portal in which not only you can visualize the satellite images, but you can have the visualization of different thematic maps which have been prepared under different programs by ISRO Department of Space, and also many other sectoral applications, societal applications. You will find all of them here, including the download of the digital elevation model, including the download of satellite images from Indian remote sensing satellite. So Bhuvan is a national geoportal, and I think we should, those who have not seen, please visit and have a look at it. Then there is another portal which is hosted by Space Application Center at Ahmedabad. It's known as Vedas. So here also you have the access to the thematic products which have been generated by ISRO over land surface. There is another portal which is called as MOSDAC. So it is again hosted by Space Application Center or SAC Ahmedabad. It's a portal for weather forecasting, cyclone prediction, and continuous weather and ocean data availability. So if you are looking for the weather and ocean related applications, looking for the products, you're looking for the information on coastal and coastal ocean and weather, so MOSDAC portal of SAC Ahmedabad is the one which you must visit. And then if you are looking for the biodiversity related information, then there are two portals which are hosted by our institute IIRS. The first portal is called as IBIN, Indian Bioresource Information Network, and the other portal is Biodiversity Information System, BIS. Okay, so these are the 5 important geo portals, and there are also certain portals which have been developed by other ISRO centers as well. You must also visit, those people who are from the northeastern states. I suggest all of you must visit the portal by the NESAT, Northeastern Space Application Center. So they have also developed certain portals which are very, very useful for developmental planning point of view, for land use planning point of view, and so on. So you must also visit those the NESAT website and the portals which they have developed if you are interested in some work in the northeastern states. So with this, I close my talk, and it is open for the questions now. If we have some questions, you can put it in the chat box, and then I would respond. If there are many, I may not be able to respond to all of them, but certain questions, important ones, I can always take it up. So this was in a nutshell, this talk was basically to give you a glimpse of how satellite remote sensing technology and the other geospatial technologies, they are being used in various operational programs across different sectors, whether it is water resource sector, or it is agriculture sector, or it is let's say the forestry sector, or it is the ocean and weather related sector, or it is developmental planning sector, infrastructural planning sector, and so on. So, and then the details, like suppose I have shown you only one slide on agricultural applications, highlighting only the major operational applications, which is currently going on in the country, but you will have one full presentation on the agricultural application. Similarly, you will have one full presentation on geology. You will have another presentation on forestry related applications. Similarly, urban and so on. So, wherein you will have a lot of information. So, if you have got certain doubts, which I may not be able to answer in this talk, please reserve your questions for those lectures to come in, and then at that point of time also you can raise your questions, whatever you have. So, thank you so very much. And then within a couple of minutes, I will look at the questions and then try to respond.